Welcome to your first video notes of the year. Today you will be learning about solving equations, and you should have Chapter 1, Task 1 notes in front of you. Looks just like this. All right, so to begin, these are all fill in the blank notes, and if you need to stop and go back, please feel free to do so. An equation is a math sentence with an equal sign. Some characteristics of an equation would include it has an equal sign, as said in the notes above. I'll write that right here. Has to have an equal sign. And it usually has variables and numbers. Bear with the length of these blanks I gave you. They're a little bit shorter than my handwriting. So a couple examples would include 2x plus 5 equals 14. So we'll put that right here in the example box. Notice it has a variable, the x, and an equal sign. A non-example would be just 2x plus 5. That would be an expression. It is not an equation because it does not have an equal sign. When solving an equation, you want to isolate the variable, and you might have heard the phrase, get the x by itself, or whatever the variable may be. You've also heard possibly to do the inverse. Inverse just simply is another word for opposite. And you may have also heard the phrase undo. So essentially, to get the variable all by itself, we're going to do the opposite operation, or undo what's happening to the variable. Next, we're going to go ahead and I'm going to ask you to flip your note page to the back. We're going to save this section down below for examples later. So go ahead and flip your page over. And if you're on the back page, we're going to pay attention right over here to the left side, and we're going to record some notes so that when you're doing the inverse operation, you'll have a quick go-to sheet. The first operation that comes to my mind is an addition sign, and the inverse operation of addition is subtraction. The other operation we're going to include is a multiplication sign, and I'm going to make that asterisk, and actually on Desmos, I think that's what it looks like as well. The opposite of multiplication is division. I'm going to draw that one, and I'm going to go ahead and draw the slash as well. So those are the 4 basic operations that you're familiar with. We're also going to show the inverse operation of a variable that's been squared. To undo the square, you would do the square root of the variable. Okay, we're going to move on over to the right section of your note page, still on the back. To solve, you're first going to look at the equation and ask yourself these questions. We're going to start with number 1. Are there any grouping symbols? And by grouping symbols, I mean these guys. We have parentheses, and we have brackets. And an example would be negative x minus 7 means the same as distributing that negative to everything on the inside. So if we distribute the negative to the x, it means the same as negative x. And if we distribute the negative x to the negative 7, a negative times a negative becomes a positive. So negative x plus 7. All right, the second step and the second question you should be asking yourself is, do you have like terms on the right side, and do you have like terms on the left side? If so, you want to simplify those guys. All right, so in this equation, we're going to look at the left side, and I particularly like to underline everything that's in common. So I have 4x's plus 3x's. They're alike because they have the same degree of x's. So I just add the coefficient on the front. I have a 4 and a 3, and that becomes a 7, and the x stays the same. equals, and I look at the right side, I see I have 5x squares, and I'm subtracting 1x squared. Remember, there's an imaginary 1 in front of that. So I'm just going to take the coefficients and subtract them. 5 take away 1 is 4, and I leave the x squared the same. All right, the next question you should ask yourself is, do you have variables on each side? If yes, then add or subtract one of them. And hint, it's better to move the smaller one. So when I compare the left side variable to the right side variable, I see that the left side one is smaller. And since that was my hint, I'm going to move it by undoing or doing the inverse operation. The opposite of a positive 3x is a negative 3x. So I'm going to take it away from both sides. When I take it away from the left, it cancels, and I'm left with a 2. And then I go ahead and do this math problem, 4 x's, and if I take away 3, I'm left with 1x. You can keep the x all by itself, or you can put a 1x there if it makes you feel better. And I can't forget about bringing this minus 1 down. Question number 4 you should be asking yourself when solving these equations is there a constant on each side of the equal sign? A constant I think I referred to earlier is just a number without a variable. So if you do have a number without a variable, then you want to, if you do have a constant on each side of the equal sign, then you want to undo the variable by using the inverse operation, which would be an add or subtract. Here's an example. All right, if we have the equation 7 equals 5x minus 3, the constant we're talking about in this case is the minus 3. So we're going to do the opposite or inverse of minus 3, which in this case would be add 3. And you're going to do that to both sides of the equal sign. I'm left with 7 plus 3 is 10. On this side, these guys canceled out, so I'm just left with a 5x. All right, and the last question you should ask yourself is, does your variable have a coefficient other than 1? And a coefficient is the number in front of the variable. Okay, so in this example, we're going to do 2 quick examples here. We have 3x equals 12. A coefficient is 3 because it's in front of the variable. So we do the inverse of 3 times x, which would be divide. And I do that to both sides of the equal sign. In this case, I'm left with x equals 4. Another example would be the equation x divided by 4 equals 6. Anytime you see this fraction bar here, it means divide. So if I were to do the inverse of divide, that would be multiply. X is being divided by 4, so I'm going to times both sides by 4. This cancels out, leave x all by itself. And on the right side, I have to complete 6 times 4, which is 24. All right, before we flip our page back over to do some examples, I'd like for you to scroll up a little bit to our inverse operations here, and just go ahead and write yourself a pro tip. If I can get my page to scroll. And this pro tip is to use SQRT in Desmos anytime we want to use a square root symbol. That's it for the notes. I'd like for you to flip back to the front. We're just going to do a couple quick examples here. And I'm going to write them down, and I'll go over them after I write them down. All right, in the first box here, we have x plus 3 equals 5. The first question I'm going to ask myself, what's happening to the x? It's being added by 3, so I want to do the inverse of addition, which is subtraction. And so I'm going to subtract 3 from both sides. That left side cancels, and I'm left with 2. Next example, we have 2x, which another way of saying that is 2 times x. So the opposite of times is divide. And we're going to divide by 2. I'm left with x equals 6. Next up, we have 2/3 times x equals 14. I gave you this example because sometimes we forget how to get rid of a fraction when it's being multiplied. To get rid of this fraction, we're actually going to multiply by the reciprocal. Reciprocal is when we flip the fraction upside down. So I know the opposite of multiply, again, is to divide, but when you divide a fraction, you actually multiply by its reciprocal. The reason we do that is because it cancels out by cross multiplication. What I do to one side, I have to do to the other. So on the left side, I'm left with x equals, now I have 14 over 1 times 3 over 2. Or if I were just to put that in Desmos or my calculator, 14 times 3/2, I would get 21. Next up, we have a two-step equation. Is anything being added or subtracted to the variable? Yes. We have a 7 that's being subtracted, so we want to do the inverse, which would be to add to both sides. Bring down what's left. And then we're going to ask ourselves, what's happening to the x? Well, it's being multiplied by 4. The opposite of multiply by 4 is to divide by 4. That's x equals 5. Another two-step equation. Ask ourselves the first question again. Is anything being added or subtracted? Yes. We have a 6 that's being added to a variable over here. So we're going to do the opposite. Cancels, we're left with n over 3, or n divided by 3 is 3. N divided by 3, what's the opposite of divide? Multiply. If I do to one side, I have to do to the other, so I'm left with n equals 9. Last example, we have, gosh, we've got a lot going on here. We have constants on the right and left side, and we have coefficients on the right and left side. Our notes suggest to deal with the constants first, and it's easier to get rid of the smaller. So -3 is the smaller of the two, so I'm going to do the opposite, which would be to add 3. Make sure you add a constant to a constant. I'm left with 11x equals 7x. Haven't done anything with that guy yet. I do have to add my 25 and 3. 28. Now I look at, I ask myself the question, are there variables on both sides? The answer is yes. So I'm going to move the smaller, in this case, opposite of a positive 7x is a negative 7x, so that's why I'm going to subtract. 11 take away 7. 4x, and I'm left with a 28. What's happening to the x? It is being multiplied by 4. Opposite of multiply by 4 is to divide by 4. And left my answer, which is 7.